Okay, so now let's talk about section 7.3, and that's about proving triangles are similar. So, recap, similar means same shape, not the same size, different size. And then also recap, that the angles are congruent, and then the sides are proportionate. Okay, so that's what the definition of a similar figures are. So now this lesson is all about triangles. So the last one had some quadrilaterals, but now we're just talking about triangles. So there is a new postulate. It's the angle-angle similarity postulate. So if you know, and this only works for triangles, that you have two angles, so there's one and here's another one, that are two sets of congruent angles that are congruent, then that is enough information to say that the triangles are similar. Okay, so then you can write this similarity statement. So all you need is two. Okay, so let's go on to this one. Are the two angles similar? How do you know? Well, they tell us that we have two 45-degree angles, so they give us one angle right off the bat. So now we're going to need to know at least one more angle, right? Well, is there any angles that you can see that are congruent? Yes, there are. Hopefully you saw these vertical angles in the middle. So since angle WSR is congruent to angle VSB, okay, so since those two angles are congruent, the answer is yes, they are similar by angle-angle. Okay, so that's all you need is two angles of the triangles are congruent. Okay, let's go to the next one. Do we have enough information here? So we have two 70-degree angles, good. But then we have a 30, but that corresponds with P, angle P, and we don't know what P is. And then we don't know what K is, but what Q is 85. So we need to figure out either what K is or what P is. And if they're equal to the corresponding angle in the other triangle, then it's going to be equal. Doesn't matter which one we figure out. Let's figure out K because these are multiples of 10. That's the only reason I'm picking that. So, how do we solve for K? Well, you're going to do 30 plus 70 plus, let's just call it K, equals what? 180. Combine like terms. 100 plus K equals 180. Subtract 100. So K is equal to 80. All right, so this one is 80 degrees. All right, now that we know all three angles of the triangle, can we say that they're congruent? Well, the answer is no. Since this one's 80 and this one's 85, then those angles are not congruent. So we can't say they're similar. So the answer would be no, because at least two angles aren't similar. Okay, so not enough information, or those just aren't. Okay, now we get to do some lovely proof. This one's a little tricky, but that's okay. We'll go over it. And if at any time you get really confused, try to rewind the video and go back and rewatch it. So we've got our statements and reasons. And then we have our given, which they give us three things. So FG is congruent to GH. And then JK is congruent to KL. And angle F is congruent to angle J. The reason is given. Okay, so on this, let's use. Okay, So on this, we know that FG and GH are congruent, and then JK and KL are congruent. Then they also tell us that angle F and angle J are congruent. So what they're wanting us to do is not say that the triangles are congruent, because they're not. They're obviously different sizes. But they want us to say that they're similar. So the only similarity thing that we've learned so far is the AA, right? You have to have two angles. Do they give us two angles of this triangle, these triangles? No, unfortunately, they only give you one, okay? But no big deal. What do you notice about the sides on these triangles? What kind of triangles, if you have two congruent sides, does that make it? Well, hopefully you thought an isosceles, because two congruent sides are an isosceles triangle. And so if you remember about isosceles triangle, that means if it's an isosceles, then that means the base angles are going to be congruent. Okay? So now we need to say that in our proof, that angle F, this is step 2, angle F is congruent to angle H, and angle J is congruent to angle L. And let's just, it's as long as you have something about the isosceles triangle, either the definition of an isosceles triangle or the isosceles triangle theorem, I'll be okay with it. Let's say the definition of isosceles, oops, that's not, isosceles triangle. I'm gonna keep it simple. So, okay, now we've got that. So now, in order for us to use AA, we had to say that F is congruent to J and H is congruent to L. Well, we do have F is congruent to J in our proof, but we do not have H is congruent to L. We have all this. So we get to use the transitive property in order to get to H is congruent to L. We know it's true, but we just have to write it in our proof to make sure. That's just how proofs work, you know. So we're going to have to use the transitive property twice, just giving you a heads up. So the first time, you're going to use these two lines right here. What does that tell you? If F is congruent to J and F is congruent to H, well then, actually let's use blue. Angle J must be congruent to angle H. And that's just the transitive property of congruence. Okay, so we've got that. Now, we're still looking for H is congruent to L. Have we written that yet? No, we haven't, but this is why I told you we're going to have to use the transitive property twice. So now, look at these two lines. Okay, do we have information there to say that H is and L are congruent? Yeah, we do, because of the transitive property. So step 4 is angle L is congruent to angle H, and we can say that because of the transitive property of congruence again. Okay, the last step, do we have angle FJ is congruent, F and J? Let's see. Oops, sorry, I was in trouble. F and J are congruent. Yep, we wrote that right here. And then do we have H and L? Yes, we just wrote that in that last step. So we do have enough information, so we're going to put this right here, down here. That's our proof statement. And our reason is going to be AA. So triangle FGH is similar to triangle JKL. And your reason, you just put AA. That's it. All right, let's do another proof. So we have our given. This one's a little bit easier. So you have your statements and you have your reasons. So first they tell you that MP is parallel to AC. That's our given. Okay, so now what else do you see about this? We need two angles. Well, I can see right off the bat these vertical angles right here, right? So let's say angle CBA is congruent with angle MBP. And why? Because of the vertical angles theorem. Okay, we've got one angle down. We just need one more. Okay, but any ideas? Well, they told us right here that the lines are parallel. Okay, so that's obviously going to have to do something with this. So if you remember from the congruency of triangles, the last half of this unit, or unit 3, part 1, anytime you saw this, I told you to look for what? The answer is alternate interior angles. So alternate interior angles theorem. That's what we're going to be using. So you have two different sets. You could either say C is congruent to M, that's one set, or it doesn't matter which one you choose, you could say A and P are congruent. I'm just going to stick with C and M. So the third step would be angle C is congruent to angle M because of the alternate interior angles theorem. Okay, now in our proof, do we have listed that two angles are congruent of these triangles? Yes, we do, so we're finished. We just need to write that step 4, triangle ABC, just like they have it up here, is similar to triangle PBM. And the reason is, AA. Okay, no more proofs for these notes, I promise. Okay, now let's go to the next page. So here's two more similarity statements, or theorems, I should say. So this is the side angle side theorem. So if you notice in this, side angle side, just like whenever you were using the congruency in the last unit, so you have to have the angle in between the two sides. So instead of the sides being congruent, this time they're going to be proportionate. So we're going to have AB and QR are going to be proportionate to AC and QS. So if you have two of the sides are proportionate, and then you have the angle in the middle is congruent, then you have enough to say that the triangles are similar. Okay? So you need two sides next to each other that are proportionate, and then the angle in between the two sides has to be congruent. That's the reason, the stipulations. Okay, this next one we were actually doing in the last section, in section 7.2, that you didn't even probably realize it. We were using side, side, side. So we did this. If you have all three sides that are proportionate to each other, if they all reduce down to the same fraction, then you have enough to say that the triangles are similar. Okay, so that's side, side, side. All right, are the triangles similar? If so, write a similarity statement for the triangles. So first, let's color code this bad boy because they are, this is looks like it's flipped or something. So that would be U and W would be congruent angles. S and X, and then T and V. So those kind of line up with each other. So first you have to figure out, are we going to use angle, oops, no. We're going to use angle, side, or side, side. Well, looking at this, do they give us any angles? No, they only give us side lengths. So those two are out. We have to use side, side. And so what did side, side say? You have to set up all three of them. If they're all reduced down to the same fraction, then these are similar triangles. So it doesn't matter which one you do. They don't have a preference. They don't say small to big or anything like that. So let's write small to big. So we're going to have three different sides. So if I say on the small triangle, side length 10 is proportionate to which one? On the big one, that would be 15. 6 is proportionate to 9. And then 8 is proportionate to 12 on the big triangle. Next step is to reduce. What can you reduce 10/15ths to? That would divide both of them by 5. That would become 2/3. 6/9, you can divide both of those by 3. So that would be 2/3. And 8 and 12, you can divide both of them by 4. So that would be 2/3. So do these all reduce down to the same thing? Yeah, they do. So now we get to write the similarity statement. And the similarity statement, just to recap, is this right here. So we're looking for something like that. Triangle blank is similar to triangle blank. So does the order matter? Yes, it does, just like in the congruency statement. So the color coding is going to help you a ton here. So let's do our reds first. We'll do U is congruent to W. Then go ahead and use the yellows. So S is congruent to X. And then finally the green. T is congruent to V. So that is all. That's what, if they ask for a similarity statement, that's all you do. Okay. This next one is a little bit harder. So looks like you have two triangles. You have this little one, and then you have this big one right here. So we have little and big. Okay, so it looks like they give you two sides. So we either need a third side or an angle in between the two sides. Take a second to think about it. They give you the angle in between the two sides, right? They overlap, so they share this angle, so that angle is congruent. So on this one, we're going to use side angle side. So side angle side says the angle has to be congruent, so we have angle K is congruent to angle K. Check, that's right. And then the sides have to be proportionate. So the side on, let's do small to big. Okay, this length right here is going to be 8. Okay, and then the big triangle, this one's a little, you gotta think about it for a second. This length right here would be 8 plus 2. So that would be 10. Okay, let's do the bottom side. So on the small, that would be 12. And the bottom side on the big one would be 15. 12 plus 3, so 15. Okay, so now in order for these triangles to be similar, we just need to reduce these, and if they reduce down to the same thing, we're good to go. So 8 and 10, you can divide both of those by 2. So that would be 4/5. And then 12 and 15, you can divide both of them by 3. So that would also be 4/5. So check, these are similar triangles because the two sides are proportionate and the angle in the middle is congruent, so that works. So now we just get to write the similarity statement. Let me see if I can erase this, and let's go ahead and do it. I'm not going to color code it on this one. You can, but I'm just not to save time. So triangle something is blank, or blank is similar to triangle something. So let's start with the top point on the triangle. That would be, we'll make this the small one, this the big one. So the top point would be L on the small triangle, and the top point on the big one would be M. The left point on the small triangle would be K, and it would also be K on the big one. And then the small right, the bottom right point would be P on the small one and N on the little one, or the big one, sorry. So that would be your similarity statement. Okay, last problem, a word problem, everybody's favorite. And we are going to draw a picture, and my pictures are going to be great. I'm just warning you now. So a lifeguard is standing beside the lifeguard chair on a beach. The lifeguard is 6 feet 4 inches tall. It's a pretty tall lifeguard. So say this guy is, or girl, could be a tall girl, 6 feet 4 inches tall. And cast a shadow on the ground. So that would look like that. That is 48 inches long. Okay. Now the chair, think of a lifeguard chair. If you've ever been to a beach, it's like up in the air. They have it on a little platform. Let's draw him a little ladder so he can get up there, or she can get up there, whatever. So the lifeguard chair casts a shadow. The shadow of the chair is going to be 6 feet long. How tall is the chair? So that's what we're trying to figure out, what the height is. I don't know if you can see it. You probably can after I do this. These make 2 right triangles that are similar because the sun is coming at the same. They are similar triangles. So before we get into solving for what this question mark is, we have a problem. And the problem is we are talking about feet here, inches here, and feet here. So we are going to convert them all to inches. Let's do that. So let's go ahead and do this. So that would be 6'4". So if you forgot how to, 6 feet times 12, that's how you figure out how many inches are in 6 feet, would be 72. And then 72 plus that extra 4 feet, or 4 inches, excuse me, would give you 76. So this is actually 76 inches. And here, to convert 6 feet, would be 6 times 12, which we already said is 72. So that would be 72 inches. So now we're ready to set up this proportion. So let's do small to big. Okay, so small, let's do the height of the thing. So let's do 76 over x, because that's the height of the big one, we don't know. And then equals the shadow, so let's do 48 over 72. Okay, use your handy dandy calculator. Let me find mine really fast. So we are going to multiply diagonally. This gives you 48x equals 76 times 72 is a big number, and that is 5,472. Now we're going to divide both sides by 48. And you get x equals 114 inches. So that is your answer. It did not specify if it wanted it in feet or inches. Fun fact, if you needed to convert that to feet, you would just do 114 divided by 12. And that would be 9.5. So it's either 114 inches or 9.5 feet, whichever the answer. This one didn't specify, but if it wanted it in one way or the other, that's how you would do it. All right, thanks for watching.